So thank you very much, Grace, for inviting me out here and the organizers. I organize Austin Python. I know how much work it is to actually run a meetup and all the logistics and everything. So it's a huge, it's a lot of work, a lot of effort. And thank all of you for coming out and to see me talk about stuff. That's actually pretty cool. So thank you very much. Before we get started. Okay, nice. So before we get started, I am giving two talks, but they're both on different technology pieces. So I'm not going to be talking generically about PyData, about Python for data, but certainly I'm happy to talk about that, in the breaks or maybe afterwards, whatever. But to get a sense of the audience here, how many people of you would self-identify as doing data analysis with Python? That's fantastic. How many of you want to be doing it in R? Great, that's oh, okay, nice, thank you. Yes, Matt is he's an employee at Continuum. That's great. So right, and so to kind of follow up on what Grace sort of said in that very very nice intro. In 2011, I was walking around the first Strata conference just here in Santa Clara. How many of you go to Strata? Just curious. Wow. That's amazing. Okay, so it's like a big data conference, right? But it's very vendor oriented. It's very, New York, Strata in New York is Strata plus Hadoop World, which tells you a lot about kind of the crowd and the messaging and so on and so forth. I don't mean this in a pejorative way. I just mean that like it's very much talking to a certain band of people, a certain band of customers. And so when I was walking around Strata 2011 here in Santa Clara, I was seeing all the exhibit floor, all the vendors, everyone showing up talking about Hadoop. There was like Revolution Analytics talking about R. And then you go into the tutorials, the workshops, the data scientists at various places giving talks, and they were using R and Python. And there was no representation of Python whatsoever. And it was clear that Python had made inroads. Python was being used. There was a grassroots adoption effort there inside many places. But there wasn't anyone coming out and really representing and saying, yes, this is good technology. You can get vendor support for it. It's real. Sort of doing what Red Hat did for Linux, right, back in the day. Really kind of put a suit on it in some sense for people who wanted to see suits. And so that for me struck me as sort of like, oh, well, in 3 years, 5 years, I still want to be doing data-related work. I want to be doing visualization work with computers. I think it's a very exciting area. But I don't want to do it in R. I don't want to do it in Java. Python's actually pretty good for this stuff. So how do we make sure that Python has longevity in this space? And one of the key things that we needed was actually to just, it's really a simple matter of marketing, right? It's actually getting out there, getting a term that people could rally around. Now we have people creating PyData meetups in places that, they create them, and then we reach out to them from the official kind of PyData organization to kind of bring them under the same umbrella and make sure that they have all the resources they need. And I think it shows how much momentum there is for Python and data analysis. And the segue here into the actual content of the talks I have is really that we're trying to build at Continuum. One of the main things we do is we build open source technology that is pushing the boundaries of not just what Python can do for data, but what can be done with data science, period. And so the first talk is on Bokeh, which is a visualization library. The second talk will be on Blaze, which is a data access and a generic computation. Some people, you might look at it and say it's a distributed computation. Other people might look at it and say, oh, it's out of core. Others might say it's generalized NumPy. Whatever you call it, it's a piece that's kind of missing right now for a lot of people's sort of day-to-day data tasks. So these two things are fundamental components, data processing, data visualization. They're fundamental components in a data exploration, data science kind of workflow. And so we want to make sure that there's open source tools that's absolutely world-class for these sorts of things. And we want those world-class things to be done in Python. So, all right, with that pep talk, so we'll talk about Bokeh. So Bokeh is a visualization library. I'm going to skip this bit. How many people know about Continuum? Excellent, great. Hopefully many of you are using Anaconda. Again, it's not sort of a vendor pitch or anything, just so you guys know, the company that we started 2.5 years ago, we're really about promoting the use of Python for data science, for scientific computing, so on and so forth, really trying to push the state of the art. One of the things that we do make is the Anaconda Python distribution, totally free for commercial or non-commercial use. Really great package manager in there called Conda, which I would be so bold as to say has solved the packaging problem, kind of. And so if you guys are interested in hearing my little rant about that, you can actually look at my PyData keynote from Facebook earlier in March, PyData at Facebook. And I have a little thing there where I kind of talk about Python packaging. But anyway, so at Continuum, we do some consulting and training and whatnot for various verticals. We have a lot of really great developers. And then also the technologies that we work on are sort of the ones that are relevant right now to data analysis. So GPUs and machine learning and predictive analytics, really data processing at scale, interop with other ecosystems, whether it's R, whether it's Java or Scala, all these various things. And then, of course, the visualization is always an important piece of that. So if you guys are interested in any of these things, I would love to talk to you about it. My email, of course, was on the main slide here. It's very simple. But basically, this is our bread and butter, right? But our key thing is that we want to make really push Python as much as possible for all these different domains. Which brings us to Bokeh. So what is Bokeh? Bokeh is a visualization library. It's a visualization library with, I would say, 5 key things it's trying to do. It's trying to do all of them, right? It's trying to do interactive visualization. We want to allow people to we want to give people a way to create novel graphics. So, and by novel graphics, that you can just sort of think D3 when you see that, right? So like things that are not just a canned function call to some library. Okay, if I want a bar plot, okay, a lot of libraries can do a bar plot. If I want a bar plot where every 5th bar is colored green, if this other value is something else, otherwise render a pie chart. No library has that function. But with Bokeh, you can compose that sort of function. So actually, one of the interesting things is that, maybe a bit of trivia, is that one of the founding motivations for Continuum was that I wanted to do ProtoViz, which is a precursor to D3. I want to do ProtoViz in Python for billions of points in the browser, of course. And I realized to do that, we needed better NumPy, and we needed better graphing libraries. And that is one of the things that led to the creation of the company. So anyway, novel graphics. Streaming dynamic and large data. We want to handle all of these situations. So streaming data coming in or really large data sets on a server, we should be able to handle that. We want to hit the browser. We want to be able to have it work standalone in just an HTML page. Zip it up or just ship the HTML over to a buddy. They're on a plane without Wi-Fi. They can still interact with the data. They can still actually have some interaction with large data. But if you have a server, you can get much more data. You can get much more interactivity. So that browser-oriented thing is one of the, there's not that many Python web-oriented plotting technologies, and certainly Bokeh, I think, is one of the forerunners there. And then, of course, most importantly, we want to do all of these things without requiring you to write JavaScript. And so there are some cases, I mean, Bokeh can be extended with JavaScript, but we want the average data scientist, the person who's actually very happy in Python land, to not have their day ruined by having to debug JavaScript, and this equals that, or that equals this, and whatever it is. So that's those 5 things. We want one library that does all of these 5 things. All right? So by interactive, what does that mean? Well, we want to have interactivity over the data region itself. We want to be able to pan around, zoom around, and things like that. If we pan one plot, sometimes we want to pan a second plot as well. When we select something, if we have large data, we can't ship 5, 10 gigs of data to the browser. Not now, at least. Maybe in a few years we can. But when we do a selection, when we do some interaction, we want that interaction itself to be a first-class object that round trips to the server, and the intersections, the interactions, the resolution of that interaction can happen on the server side. We want to be able to resize and kind of mess around with the plot. We want to have kind of a very configurable and flexible data inspection and hover sort of capability. If you go to the Bokeh website and you look at our gallery, okay, this Bokeh web. Oh, actually, do I already have the gallery loaded? I do. So the gallery has a number of examples here that show you, yeah. So if we just click on one, for instance, here, this is all right. This is a map of unemployment in Texas. Loads up the code. Okay, and so now as I mouse over each of the little regions, that's nice. It tells me the actual unemployment value, but most importantly, I can sort of interact and zoom with it. I can kind of pan around, so on and so forth. There's also, many different kinds of plot styles that we can do. So this is just kind of one example of what we mean by the interactivity. There's also, so once this loads here, yeah, this is a quiver plot. Different varying colors and alphas and line lengths, orientations, and so on and so forth around a kind of a Mandelbrot set. This is a heat map. Actually, this is, I think, the New York Times has something like this. But it shows you historical heat map, historical US unemployment data. And so this is the sort of thing that we mean. And also, when we talk about client-side resizing, it's like this kind of capability, right? Just, it just works. So that's what I mean by interactive. Novel graphics, what I mean by that is the ability to create charts that are not necessarily, again, canned. So on the upper left, actually is a chart that comes from Seaborn, the Seaborn statistical plotting library. It's a relatively newer library to Python Viz space, but it's fantastic. And we're able to actually render the plots that it generates into the browser. And so here we have a violin plot showing distributions for different categories. We have a dotted line for the mean, and we have lines showing kind of the standard dev above and below. In the middle here, we have some various, just categorical data. Over there is an interaction diagram. Actually, that one's also. Some of these are already on our. Some of these are on our gallery as well. So this is the. Our doc. We had a new release today, and the docs refresh has made me a liar. No, it's not. Okay, here it is. This is co-occurrence of characters in the novel Les Mis. So you can see who showed up in how many scenes with who. This bright line, of course, is Mr. Valjean with everyone. So these are the sorts of things that you can do in Python now. And again, woohoo, resize, right? So anyway, novel graphics. And over here on the upper right is actually, how many of you recognize the plot in the upper right? Show of hands? Okay, it's actually a plot that's in the visualization literature that it shows the efficacy of antibiotics. A gentleman named Burton made this, and you generally see it as just this picture. It's this static picture. We want to show, well, you can do this in Bokeh. But what you can do with most of the static pictures that render this is actually interact with it. And the actual interaction here, you could sort of say, well, how useful is that with this? But it's we could do it. But anyway, so the point here is that you can make novel graphics like these. The interesting thing about this axis is that he inverted, or the interesting thing about this plot is he inverted the sense of the axis so that efficacy is actually shown. The efficacy of these drugs against various strains of bacteria, they're shown by length. So there's an inverse mapping of radius, and you can do that with Bokeh, no problem. And there's also periodic table. I just cut out. Okay, periodic table, for instance. Now, you might not think that a periodic table is really a plot, but it is a tabular display of data, and it's something we can do within Bokeh as well. We're just, and I'll show you the code for this in a little bit, but this is actually something that our plotting system can generate. So this is another example, for instance. Here is a graph that we just have a line down x equals y, and we have a number of different points, and we want to show the projections against x equals y. It's a pretty little picture. Sometimes can be useful, actually. Right? You might want to see, well, when projected against the x equals y axis, which point is ahead of which other point? Are there clusters, so on and so forth? And I don't know how you would do this in other plotting systems, how you might go about creating a plot like this. But in Bokeh, it's 15 lines, right? And that includes the imports and the data, kind of the random data generation. So it's putting this kind of power. So like with D3, you can do this, and you would end up, I don't know if you guys have seen sort of, someone has a Tumblr or something which shows like failed D3 experiments or something, like the process of generating D3 plots. And you just have like polygons like out to, over here, lines everywhere. And with D3 you can do it, but there's a lot of debugging, there's a lot of JavaScript and so on and so forth, and we want to make this kind of easy and painless for Python programmers. So this is what I mean by novel graphics, right? And again, no JavaScript. So again, the unemployment map, this other kind of nice little distribution plot, both of these, just a few lines of Python. Very, very compositional in nature. We also handle streaming and dynamic data. On the left is a screenshot of a spectrogram demo, which I will run, and on the right is this kind of animation demo, which I'll show you that in a little while as well. But first I'm going to run the streaming demo. And what this is actually doing is, it's a little Flask app, and then there's a little Bokeh-based dashboard on front. And what this is actually doing, don't make me a liar. Come on, where's the data? Did you guys hear that? Okay, so one second. I'm going to unplug the audio here off of this thing and see if that might help. Okay, internal microphone. Well, we'll come back to that demo. Yeah, that's great. No, that's totally expected, actually. I expected that when it broke to do that. So that's interesting. Okay, let me try that. Oh, okay. I see the problem. Web apps, yay. Okay, so what this is showing, yeah, when you guys see this demo, you'll see why I went through the trouble of trying to get it working, okay? So what this is actually doing is it's using PyAudio to sample the microphone on my laptop and then do a real-time FFT, and it serves up this data as JSON every time you hit this web endpoint. And so this front end is just basically pulling that about 20, 30 times a second, slapping data in, and then using Bokeh to render all these things. So here we have, this is actually the time domain signal. This is the Fourier transform of that signal. And this is the kind of the rolling image spectrogram of that. So if I whistle into the microphone, you should see a very clear sinusoid here. And you should see a kind of a bright line across the middle there. Right, so this is street, wow, look at that. More power, yeah. So, well, there you go. There's the frequency distribution of your claps. But this is the sort of thing, this could be, this is Web 2.0 made real, right? I mean, this is JavaScript. It's actually doing the color mapping in real time. All the great guys at Google, Mozilla, Apple, all these places that are writing, fast browsers, Microsoft as well, all these people building fast JavaScript engines have rendered this onto us, where we can actually go and write color mapping routines in just plain JavaScript and have it run in real time. It amazes me still. So anyway, that's that demo. That's actually checked into the GitHub. I mean, you can kind of play with it on your own. And the animation demo, the one on the right, I will show that actually later once I talk a little bit about the architecture. But this is what I mean by streaming data. Big data, right. Okay, so back to our browser. And this is actually, what this is showing is it's image slices stacked. There's an image cube. This is ocean temperature data from NASA satellites. This data is courtesy of JPL. And this slider lets me move backwards through time. I'm able to actually, see here, I may have to actually refresh this, but this actually should, okay, there it is. You can actually see it refreshing a little bit. And these sliders on the side and below, as I move this, okay, let me refresh this whole thing because something is not right with this connection. Okay, so as I move this slider around, you can sort of see the plot below updating. Right? And what this is doing is these are cutting, if you can imagine, these are cutting a plane, right? Maybe I'll use the cursor so people on TV can see me. This is cutting a plane through here. This is cutting a plane through here. And so this controls the bottom one. This controls the right one. It's a little bit to explain. But the point is that with this data, I can actually, again, I can go kind of zoom in. And as I zoom in, what you'll see is that the data actually will refine from the server, and it'll show me more detail. And anyone who's used, a web mapping system, this is totally familiar, right? Like, what's the big deal? The big deal is that this is 4 gigs of data that's being real-time downsampled on the server for me. And you can build this in Python, right? And this is not just, a lot of systems that do this kind of thing, those of you, how many people here do GIS data and geo-based mapping? It's tile servers, right? They have engines that go back there and render a lot of images, and they have some smart routing to give you the right tile. But really, that's all it's doing. This is actually doing real-time rendering of the data off the server. So if there was data streaming into this, it would just work. And it's not just for 2D. Again, not a tile server. Here is 1D. Oh, by the way, this is 4 gigs of data. And I do this demo over conference Wi-Fi, right? Because what's happening here is that the interaction I'm having with the viewport, the Bokeh runtime system in JavaScript is communicating not just the viewport dimensions in data space to the server, it's also giving it hints about the resolution. And that allows the server to serve up the right level of detail. Over here, we have 3 stock time series. I can kind of move them around and pan and plot, pan and sort of zoom them. As I zoom in, you'll see more data filling in. Same kind of thing. So that same technology, or that same capability that we had for the 2D applies to 1D. And to plot these lines here, to do this plot, you just have to change the data source from being, like a pandas data source to a remote data source. 1 line change. And this is about 2 million points here across 3 time series. So big data. And then the other thing is that we can work in standalone mode, where everything's embedded into a single HTML file, just everything, the runtime, the CSS, everything, all in one file. Or we can run in a server-based mode, where the data is on a server. And both of these modes also work inside IPython Notebook. So here I have an IPython Notebook. One of these places is there's my IPython Notebook. And so this is actually a nice little overview. You just walk through and you sort of see what we can do here. If we do circle, it just draws circles basically with these data. And I can pan around. This is all very, very nice. I can go and do something more sophisticated. So if I load this federal automobile mileage data set, it's in the Bokeh sample data. If I load this up, I can go and render this interesting plot where I draw bars at plus and minus 1 standard dev for each year. Basically, each year I'm rendering the, I think this is the miles per gallon, right? The average miles per gallon. And so what I want to do is I want to render the Japanese cars in red and the American cars in blue. There was actually no political commentary intended with this plot. It was just data, all right? The data just speaks, right? But what you can see is actually here in 80, there was a kind of a big jump up. Everything was trending upwards. In 80, there's a big jump. And the Japanese cars kind of clearly collectively did better than the American cars always. But this is, again, interactive, zoom in and out. And if there's some other parameter that I wanted to tie in, like with the American cars, if I wanted 6-cylinder versus 8-cylinder versus 4-inline, I can choose different alpha levels for those, and that would be just one parameter to set here. Because what we're doing is we're mapping glyphs, we're mapping visual markers, or we're vectorizing them over a table, over a column, over a data set. And that is a very, very different way to think about plotting. It really affords this compositional approach. And then we as Bokeh developers just make sure that it runs on the web for you, right? So additionally, what we can do is in this case we're creating a grid plot of 3 different circle plots showing different facets of the data set plotted against each other, and they're all interactive, and they all have linked selection because we passed one data set object in. Right? Link selection, no problem, no sweat. And this is all this functionality is baked into the JavaScript, baked into the DOM of this output cell in the notebook. So if I sent this IPython notebook to you, you don't have to have Bokeh installed. You open it up and you would see this interactivity. It's just there. And the only thing you had to do as a coder to make this work is to actually create column data source and pass that data source in to each of these calls and name the columns by name, as opposed to passing in literally an array or a list of values. That's all. And that the fact that they're all on the same data source object gives you that linking implicitly and automatically. And a question that I always get asked is, comparing to other sorts of things that are out there. Well, actually, sorry. The first question I always get asked is this D3? And the answer is no. We use Canvas. We have our own Canvas-based rendering system. It's a full runtime in JavaScript. I'll talk about that in a second. But this is not. We don't use D3. We don't have anything against D3. It's a great tool. I think the term that's used is that it's a great artisanal tool. And so if you have a week to go and build a gorgeous infographic to put on the front of the New York Times, great. But if you don't have a team of designers and JavaScript programmers to help you, and you're just doing data exploration and you got a ton of stuff to do and you want to get it done this afternoon, we want to have a tool that basically democratizes this kind of data visualization for people, makes it accessible. So compared against some of the other libraries here, and if anyone has objections with this chart, any questions, I love to take them. I'm not trying, and again, I'm in no case ever trying to denigrate other plotting packages. I'm the author of another plotting package called Chaco, and I'm friends with developers of many of these other things. And so the comparison here is simply to talk about kind of the capabilities that we're trying to hit in Bokeh. Again, those 5 points in the very first slide, right? We want to do all of them. We don't want to have interactive JavaScript, so I'm going to do this thing. But I want to have Matplotlib interfaces, so I'm going to do this thing. And it's really big data, so I have to do this other thing. No, all of it in one place. All right. Any questions about this? Do people want me to go into this in any more detail? Yes? The asterisk, yeah, good question. That was the question I asked. The asterisk means yes, but with caveats, right? So interactive visualization in Matplotlib, there's 2 ways to do it. One is the naive way, right, where you kind of just use the buttons and the interactivity that's built into it. If you want to do more sophisticated things, there's an event architecture Matplotlib you can hook into and write kind of some custom stuff. But if you want to do interactive visualization at the scale that we did, like with Choco, or there's some things we're doing here, it's really hard to do it in Matplotlib. Like Jake Vanderplas, I think, has pushed the envelope the furthest in this regard, showing all sorts of cool things you can do. But you have to really understand the rendering model. At that point, you're just using Matplotlib as like a 2D rendering surface. And you don't have a lot of the plotting infrastructure behind you. Novel graphics, again, you can do it with Matplotlib using the rendering architecture underneath, but you're just using it as a drawing surface then. All these things, those are the asterisks of Matplotlib. Like the answer to everything with Matplotlib is, yes, it can be done, but like you kind of have to reach into the bowels of the thing. Yes? Displaying node link diagrams? Yes, so node link diagrams I didn't actually put on here, right? Which is actually a very nice, interesting omission to point out. Node link diagrams, D3 does a very sexy version of those, right? Like you move them around, they jiggle and they wiggle and everything. It's very nice. I actually do, Bokeh is actually funded by DARPA to a large extent, and it's part of their big data program called XData. And there's a lot of graph problems to work on in XData. And by and large, when you start doing graphs at scale, it's just hairballs. They're pretty hairballs. They can convince various people with budget that you have a big data problem. But in terms of actually giving you insight in like intuition, like, that cluster, bad. You know, like it's really, really hard to get some of that from node link diagrams. So when you have nodes and edges, you know, less than, you know, a couple thousand kind of thing, they can be very useful. But once you get to more than that, then it becomes very difficult. And we haven't tackled the node link diagram thing. We may actually, for node link diagrams, just call out to D3. Because one of the difficulties with D3 is that because it uses SVG, there's just fundamentally a performance limitation. Once you hit a few thousand points, it just gets very slow. And there's like literally nothing you can do about it. Like you could use a canvas backend and some other things, but then you lose some of the hitting and all this stuff. So like fundamentally, you're paying the browser tax for using a DOM element, right? The browser doesn't expect to animate 20, 50, 100,000 DOM elements. It just doesn't do that. So yes? Yeah, we're actually not using IPython for that purpose. We have different levels of interface in Bokeh. There's a low-level glyph interface, and actually there's a low-level object-oriented interface. Then there's a higher-level glyph interface, and above that there's a charts interface. And I'll talk about that later on. So people who are not as savvy with Python, you know, don't have to try to go and compose. You know, you don't have to pay the composition tax if you're doing something relatively straightforward. And also our Matplotlib compatibility. You can take any Matplotlib, not any, but most Matplotlib figures. You can turn into Bokeh with just one call. So our gallery actually shows this at the bottom. This is how we get the Seaborn plots. So Seaborn uses Matplotlib to render. You can't see the code there. But this is fully interactive Seaborn plots, very nice. And the code is that. And you just use Seaborn at the very bottom. You just say to Bokeh. Oh, you can't see that at all, can you? It's still, how do I do? Oh, you know what? I'm good with computers. There you go. Now can you guys see it? But literally, it's just to Bokeh. And we walk the figure object graph of Matplotlib, and we export that into our object graph. And this, of course, applies also to the ggplot library for Matplotlib. I don't know how many of you guys know that one, but like this is you know, a density plots using ggplot.py, interactive with Bokeh, and you can even actually apply the XKCD transform that's also supported. So we have interactive XKCD in the browser with just a few lines of code. So so the Matplotlib compatibility is another way for people who are not as familiar with, or who don't want to get into the bowels of the composition stuff to be able to do easy plots. One thing we didn't mention is that actually if you guys have more questions and whatnot, at the end, there'll be a longer Q&A session after my second talk, and I want to answer everyone's questions, but I will never get done with the presentation. I took all the questions, but hopefully going through some of these other slides will answer some of the other questions. So I'll dive a little bit into architecture. I think many people in this room would be very interested to know what we're doing, how we're doing it, where's the magic, et cetera, et cetera. So by way of contrast, if you think about previous or kind of a lot of existing JavaScript code generation, what you do is you basically have a big template string, some big triple-coded string with some JavaScript, you know, script, blah, 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 and then you got some variables that you're going to paste your data into. And that's your template file. And then your server goes, you know, your server goes and renders this template, and it spits a bunch of HTML back to the browser. And then inside the browser, inside the JavaScript runtime of the browser, these JavaScript libraries have full control of your code, and they control all the interaction with the user. So in this kind of naive model, some of the downsides are it's one shot, you send this over, there's no MVC interaction, there's no data streaming. If you're a little bit more sophisticated, you can use something like Float, for instance, does have a callback API where you can go and reach back to the server for more data. There's a lot of wiring you have to do. What we did is we wrote our own standalone JavaScript, first-class, like honest-to-goodness JavaScript rendering library called Bokeh.js. You can use it just from JavaScript. It works with JS Fiddle. It's all written in CoffeeScript. If you look at GitHub, actually the GitHub stats for Bokeh indicate it's mostly a CoffeeScript project, not really a Python project. So we wrote a big CoffeeScript, not big, but we wrote a pretty nice, I think, JavaScript plotting library that takes a lot of the concepts in from Choco, which is the previous kind of rich client rendering system I did. Some of the concepts from there, improve some of them, simplify some of them, and really it's a scene graph-based visualization system written in CoffeeScript. You can use it just from CoffeeScript or just from JavaScript. But the fundamental thing that's different about Bokeh.js is that it is built to be driven by server-side models. It's built to be driven by JSON. Most of the JavaScript, we looked around. We didn't want to write our own JavaScript rendering system. I mean, that's kind of crazy, right? We're Python programmers. We don't want to write JavaScript. And we looked around, and every JavaScript plotting library you find is designed for JavaScript programmers. They assume you have NPM. They assume you know the difference between Grunt and Bower and what AMD means. No, not the chip company, right? Like, they assume all these things that we really don't care about as Python data scientists. So, but fundamentally what they have is a plotting system that says, give me your data, all of it, in the browser, and then I'll go and do whatever you told me to do. And that's the only interaction you have with the plotting system. We built Bokeh.js to be essentially a scene graph that's reactive to models that can be either embedded in the page or driven by server side. And we did all the right JavaScript things. Like, we're using Backbone, we're doing all these like right things. But we wrote this JavaScript to prevent to help other Python programmers keep them from having to do so. And so the architecture we have here is that in Bokeh, in the Python interface, when you create these like compositional graphs of things, you actually end up with an object graph. And that object graph is pure Python. It actually doesn't, so Bokeh doesn't actually have a hard dependency on NumPy, Pandas, or even Python 2. It works with Python 3, it works with PyPy. Okay? Because all you're building is an object graph. And that object graph gets turned into JSON, which is sent over to the browser. And the JavaScript, the Bokeh.js runtime in the browser, it looks at the JSON and reconstitutes the scene graph, a reactive, interactive scene graph representing the plot, rendering a canvas. If you run the Bokeh server, if you run Bokeh in server mode, then actually we use WebSockets and we communicate back and forth. And essentially what you have is actually browser or client server cross-language RPC via JSON. So what that looks like, more concretely, is we have, this is a script, iris.py. This is the script that generates the iris plot, one of these, this one right here. It generates this iris plot. Very nice, lovely, pretty, very, very well-known data set. And you can see in Python, all we're saying is okay, I want you to output this to a file. I want it to be iris.html. Resources are relative, which is how we path the JavaScript and whatnot. Doesn't really matter. The point is outputting to a file, and we're just going to call scatter. There's really only the two lines that are really important here. And what this actually does is it generates this HTML file. And you can see, just by visual inspection, not being able to read the text at all, you can see in the middle is a giant pile of JSON. If I remove that, you can see the structure of this HTML file is relatively straightforward. Right? At the very bottom is the body, which is just one div. It's got a class, which is a plot div. It has a UUID. And then in the JS itself, there is, in the JavaScript, basically, when the page first loads, we go and we find that UUID, and we say, here is our JSON collection that represents all the models, all the model state representing this plot, go. And it basically, into that div, it builds the canvas, it builds all these various things. And the JSON, what that looks like is very straightforward. It's what you'd expect if you took a sane object model of a plot and just serialized it, right? And the thing that's interesting about this is that Python, if all the Python is doing is generating JSON, well, other languages can generate JSON too, right? And so we actually have a Scala interface. And you can use Bokeh Scala and write Scala code. We have all of our low-level examples ported to Scala. And you can just write the Scala stuff, and it generates a pile of JSON, and the Bokeh.js runtime in the browser doesn't care where that came from. Likewise, Julia, there's one contributor, lone contributor right now working on the Julia bindings. But we could see, there's no reason that we couldn't do this for R, for MATLAB, for C++, for Java, you name it, right? It's just generating JSON. And so we just had a release today, 0.6. That's why the link is not a blog post, but rather is this horrendous Google Groups link. But if you look at our Twitter and whatnot, we'll have a blog post in the next day or two that talks about the new features and whatnot. But some of the cool things that we've got now are additional things in Bokeh.charts, which is the high-level charting interface. If you want to just call a function and get a plot, and you don't care about the compositional stuff, that's a great interface to do it with. We have a table widget as well. I'll show you a screenshot of that in a second. We've got now Python 3 support in the Bokeh server. So for a while we were using a server-side technology that was only supported on Python 2. Now we've changed it up, so now it uses Python. It's Python 3 compatible. More documentation. One of the things that I'm actually very proud of is that if you go to the Bokeh site, if you want to understand some of the technical vision and details, you can scroll down to the bottom and read some of this stuff. But if you go and look at the user guide, the developer guide, there's actually a lot of information here. Okay, that was a poor example. There's a lot of information. there's a lot of information here that tells you about the various plot properties and all these various other things. If you look at the Bokeh.js, if you look at the developer guide, that's where we actually have more information on how do you go and build the JavaScript library itself, like all this stuff. But we also have here under the Bokeh.js section, I want to show you. Some of you seem to be interested in the fact that it was a standalone JS library. If you look at the JS interface reference, if you click on any of these things, so let's say we look at, quadratic. Each of these things, actually, if you click on them, it takes you to a JS fiddle, and you can play with Bokeh.js right there in your browser. So here's my data. If I change this orange to black, and dimensions, let's do 500 by 500, and do run. There it is. Right? Oh, tools. Let's change that to true, so we can actually kind of do something with this. Really? I can't scroll? Wow. Oh, there it is. Okay. So now I have some tools. Move around, zoom, pan, all JS fiddle, all just JavaScript. No Python involved at all here. And one thing I didn't show you, after talking about the architecture, this picture, again, this RPC thing, I want to show you an example, a demo, basically, that really drives this point home. So here I'm going to fire up, sure, I'll do this one. Great, I've got a Bokeh server running, and I'm going to run, this is an animated plot, okay? So this is nice, it's kind of cool. It's not as sexy as some of the D3 stuff, but it's still pretty cool. And I can do, box zoom and all this stuff. And the question is, how is it doing this? Why is it animating? Is there a JavaScript thing running here? What's going on? So let's look at the code. How many are Vim users here? Nice. I heard a woo way in the back. It's awesome. So this is the code. Hopefully none of you guys are afraid of the Python code here. There's some stuff at the top just to do some computations and whatnot. And what's happening is there's only one glyph being rendered, which is an annular wedge. Okay, so if we look at the plot again, let's reset our view. There's a series of annular wedges. And what I'm doing is each refresh cycle, I'm changing the inner radius and the outer radius. I'm rolling the inner radius one direction, rolling the outer radius the other direction. So if you look at this code, I've got a while loop, and I'm setting, I'm rolling +1 and rolling -1 for rmin and rmax. And then I set this updated data on the data source, and I call store objects. That store objects call basically goes and updates the object state on the server. And so again, the implication of this is that while loop is why this is updating. If I pause that and background it, no more updates. Still interactive. But there's no more server updates. There's no more, my Python script is not pushing model updates into the server. Therefore, the server is not pushing WebSocket notifies to the client. Therefore, no updates. If I resume, it's there. And so that cross-language RPC, that object model thing is just really, really fundamental. And it's a fundamental part of the architecture. But it's also what it gives rise to then is it gives rise to the ability to, plots are only one kind of model that we can kind of reflect, right? I'll skip that for 1 second. We can actually build widgets, and we can build interactive applications on top of this. Because a widget is not a plot, but it is some visual representation of some model state that could be stored on the server. And so some of these things, for instance, the population plot, I'll show you this guy right here. This is a dashboard that represents the population demographics, male, female percentage of the population by age for different countries and various things in the world at different time frames. So here we can look at the United States of America versus the world average. And you see that we have much longer life expectancy across male and female populations. This is 2010. If we go back and look historically, in 65 actually, 1 second, we're not doing nearly as well, right? And so compared to 2010 actuals, and here we can actually explore and say, okay, well, what about let's compare to I don't know, the World Bank low-income economies, right? And you can see actually a much more terrible curve for them. And this kind of data exploration, this kind of data dashboard, each one of these interactions I do with this dropdown, it's round tripping to the server. The server can do whatever it wants to in Python and push updated data into the data sources that drive this plot. And it's all done in Python. So this dashboard, how many people here are familiar with Shiny and R? Heard of it? Seen it? Right. So we're definitely building technology that is, I think, comparable to that kind of thing. But actually with more, I think, a little bit more legs. There's another one that I want to show, which is, here is, let's see, it's actually, maybe I'll go back to the slides real quick. Yeah. Oh, here, this is what I want to show. So another thing we're doing is we're actually using some of this capability to go and build things like cross-filter in Python. So we're building bigger apps, right? So they're not really just a dashboard, a little tool. It's actually using the Bokeh technologies to build something more significant. So here I can plot different distributions against different things. Change it to a line plot. Well, it's not a great plot style for that. but I can go and drag in okay, well, I want to filter actually by miles per gallon, and I want those middle ones. And let's say I want to facet based on the number of cylinders. So this is facet wrap, for those of you familiar with ggplot. And all of this, by the way, is totally interactive, right? All these are interactive. We don't have the link brushing turned on here, but this is the sort of thing that we want people to be able to do with their data. Do it in Python, open source, and it works on large data sets on the server side. So this, if you guys are interested in pushing this forward, if this is exciting to you, we want contributors. We want people to come and use our stuff and tell us, what's good about it, what sucks, what things you wish worked, so on and so forth. So the cross filter. Is there anything I missed here? Yeah, there's a blog post coming soon, so definitely look for that. If you want to contribute to the project, we really, really would love to get more input. I know we move very fast as a project. I mean, it's actually the development has been extremely active. I don't know that showing the graphs is going to really help, but we're almost at 2,000 stars. So if anyone can help us get over 2,000, that'd be great. But actually, we have now 5,800 commits. We're very active on the issues, very active on the mailing list, and definitely follow us on Twitter. We're also looking for people who are interested in doing some design work for us, doing some front-end dev. If you want to do some JavaScript work, or you have friends who want to do it and want to get into data visualization, get into a project, we could really use some of that help. And also, if you have a company that's doing data viz stuff and you can't hire a D3 person at the right rate, or you don't want to be doing, you don't want to own a whole stack of D3 kind of thing, we would love to talk to you about maybe doing some work for you on top of this open source technology and help drive this forward. So the one last thing I will mention, I actually have no idea when I'm out of time, so I'm just going to keep talking. But the last thing I would mention is that one of the things that we're really doing that's really important is we're actually trying to push the forefront of visualization technology, and we're doing it Python first. So one of the things that really, really irritated me, I would say, not too much, but irritated me a little bit, was walking around, just talking to various people about visualization. A lot of people in data analysis world do come from R, or they have friends that use R, and they have these gorgeous plots in ggplot, right? And then there's other people I talk to who are I never want to touch ggplot again. Screw that. And I'm friends with Hadley, so we're good terms. But the point is that this idea that Python has to play catch up to something else. Python, let's build a wrapper to X, right? Or let's do whatever. No, we can do cutting edge visualization work just in Python. And so one of the things that we're doing, again, part of the DARPA funded efforts on big data, is we want to visualize, like I said in the very beginning, billions of points. How do you visualize billions of points when you only have a few million pixels, right? how do you do that downsampling in a perceptually meaningful way? So there's work that we've been doing on a technology and a technique called abstract rendering. We've actually published papers on this. We're getting more and more interest in this. But it's really about this idea of not only doing perceptually accurate downsampling for you, but doing it in real time and doing it for free. So here, if I go and this one is not the server I want to run. This is the server I want to run. And if I go and run, yeah, there we go. So this shows you what I mean. This is a plot of the census data, 1 dot for each census tract, and we're automatically computing the alpha correctly to show you, actually this is logarithmically scaled, I believe, to show you density of various regions in the US. And as you zoom in here, the server actually goes and rebins and resamples and gives you kind of more accurate representation as appropriate. And you see it's filtering in more and more here. And we can actually go and do automatically produce contours for you. One of the things that we have been kind of researching is how to do contours in areas where there's too much data and then still showing the sparse points outside. And we have other techniques that we've been working on in research mode, essentially, on doing this kind of thing for time series data. So all of us have probably seen the IT plots or whatever plots. They're just like squiggles of lines and then like more squiggles up here and more squiggles down here. We want to do one better than that. And so this is the sort of work that, and additionally, one other thing to point out is actually if you look on the right, this is adjacency matrix data. So if you guys look at graphs, I was kind of dissing node link stuff earlier. One of the things I think is an interesting way to look at graphs, and people have done research in this area, is with adjacency matrices and other kinds of matrix style representations. But even when you render adjacency matrices, you tend to end up with like a lot of overplotting. So we take care of some of that here with some of these methods. But on the far right, the black stuff, what that's showing is actually a different kind of data shading approach, where we actually render not where the points are, but where they're not. We're actually rendering sparsity. And it's just a custom data shader, and we can actually run on the client side. So you can run this on millions, hundreds of millions of points on the server side, and on the client side, you've been configuring how you want to shade the data and the relationships, the visual statistics within each pixel, that sub-pixel shading of data. Again, making that available so that you can just write Python to do that. So this is the sort of stuff that I'm very, very excited about. No one that I'm aware of, just honest to goodness data viz, info viz space is really pushing in some of these areas. People are doing some things like this. So nanocubes, immense, if you guys are familiar with some of that work, they're ideas in a similar vein. But in terms of a generalized architecture for doing data shading at a sub-pixel level, dynamic data shading at a sub-pixel level on really scalable and distributed infrastructure, that's stuff that we want to do and bring to Python first. So anyway, with that, I think I've kind of gone on long enough. If any of you have other questions, I don't know, Grace, or anyone, hi, do you think we have time for questions? How are we doing?
I think it'll be good for us to leave questions, do the questions after
At the second talk. Okay, great. Well, thank you guys very much. So that's Bokeh.